Okay, let's look at a word problem now. Problem 2, using linear programming to maximize profit. So we know here we're going to be working with profit, and that's kind of nice, just having a meaning behind our situation. So in business, you are screen printing t-shirts and sweatshirts to sell at the Polk County Blues Festival, and you're working with the following constraints. So first of all, we are going to have two variables. We have t-shirts, we have sweatshirts. Let's figure out what we want to call each one. And I'm going to call t-shirts, the number of t-shirts, X. And then Y is the number of sweatshirts. Okay. We know it takes 10 minutes to make a one-color t-shirt. It takes 20 minutes to make a three-color sweatshirt. You have 20 hours at most to make shirts. So our information's kind of lined up for us here. Just based off these three, takes 10 minutes to make a one-color shirt, to make a t-shirt, 20 minutes to make a sweatshirt. We have 20 hours at most to make shirts. Let's come up with an inequality here. Well, 10 minutes per t-shirt is 10x. 20 minutes per sweatshirt is 20y. At most 20 hours, we have less than or equal to here. But 20 is in hours, where these are in minutes. We need to figure out how many minutes is in 20 hours. Well, there's 60 minutes in an hour. So 20 times 60 is 1,200 minutes. So 10x plus 20y less than or equal to 1,200. Then it says supplies for a t-shirt cost $4. Supplies for a sweatshirt cost $20. You want to spend no more than $600 on supplies. So these three pieces are also grouped together. Everything's talking about cost. Each t-shirt's $4, so that's 4x. Each sweatshirt's $20, it's 20y. The total cost, no more than $600, less than or equal to 600. And then it says we want to have at least 50 items to sell. This piece kind of stands alone. At least 50 items. That would include the number of t-shirts and the number of sweatshirts. X plus Y greater than or equal to 50. Then it says the profit on a t-shirt is $6. The profit on a sweatshirt is $20. How many of each type shirt should you make to maximize your profit? Whenever you see something like this, this is our clue that our information here is going to determine our objective function. And that is where we are going to plug our vertices in to see if we can find our maximum or minimum. All right. So profit on t-shirt $6. That's 6x. Sweatshirt's $20 is 20y. That's going to tell us our profit. So this is our objective function. All right. There's one other thing we need to think about as far as our constraints go. Okay, so down here we kind of have our constraints filled in. 10x plus 20y is less than or equal to 1,200. X plus y is greater than or equal to 50. 4x plus 20y is less than or equal to 600, just filling these in. The two other things to think about, well, we can't sell a negative number of t-shirts. So x has to be greater than or equal to 0. We can't sell a negative number of sweatshirts. Y also has to be greater than or equal to 0. So always kind of try to keep these in mind too. Can I have a negative number? Does it make sense to have a negative? If not, there we go. We need to have those greater than or equal to zeros. And then our objective function we said was 6x plus 20y. So again, we kind of already figured all of this stuff out, but there we go. All right. 12, our region is kind of already shaded for us, or not shaded, but our line's already drawn here for us. But let's kind of go through that process again. If I was trying to graph 10x plus 20y is less than or equal to 1,200, we have to get y by itself. Subtract 10x first. and then divide by 20. This would be 60 minus 1/2 x. 60 minus 1/2 x, looking at my graph here, that's this line, 60 minus 1/2 x. Less than or equal to, we're going to shade below. We're going to go through that same process again with my next inequality. X plus y is greater than or equal to 50. Get y by itself. Y is greater than or equal to 50 minus x. Okay, that inequality, or that line, is right here. So I'll use a different color. Greater than or equal to, shade above that. Shaded above. (4x plus 20y is less than or equal to 600. Get y by itself. 20y is less than or equal to 600 minus 4x. Divide by 20. 30 minus 4 over 20 is 1/5 x, which is this line, less than or equal to, shade below. And then our x is greater than 0, y is greater than or equal to 0, just means we're in this first quadrant. So looking at my graph here, I have a vertex at, or my solution is really this triple shaded region. I have a vertex right here, and this vertex I'm going to give you is 25, 25. I have a vertex right here at 50, 0. Right here is 100, 110. And then right here is 120, 0. And usually the vertices will be a little bit easier to see than this one. Now that I got my vertices, we have to evaluate because we're trying to maximize our profit. So we evaluate each vertex in our objective equation, our objective function, which we said p was 6x plus 20y. So plug each vertex in for x and y. P is 6 times 50 plus 20 times 0. Work this out, we get 300. 120, 0. Plug it in. 6 times 120 plus 20 times 0. Okay, 6 times 120 is 720. 6 times 100 plus 20 times 10 is 800. And then 25, 25, 6 times 25 plus 20 times 25. This ends up being 650. So I went through that kind of fast, but that's our process. So our maximum profit happens right here. Our maximum profit is $800. When 100 t-shirts and 10 sweatshirts are made. So hopefully you're kind of see some real life application of this. Like, what is it best? T-shirts are cheaper to make, sweatshirts, they're more expensive. So who's gonna buy what? I know personally, like, I'm more likely to buy a t-shirt than a sweatshirt because of cost, but we still want some sweatshirts to be sold in this situation to make the most amount of money. So again, we'll practice this, but really a lot of it is just graphing our systems of inequalities and remembering how to do that correctly.